Hello everybody and welcome back to another lesson in Algebra 2. Today we're going to be working with statistics. We're going to keep working in this section of probability and statistics, and specifically today we're working with analyzing data. Okay, and a lot of the things we talk about today are going to sound familiar or maybe even elementary. But there's also going to be some new, more in-depth analysis of things that you've talked about before. So, our goal today is to calculate measures of central tendency, and then, we're not going to actually work on drawing box and whisker plots, but we are going to talk about how to find things that are in box and whisker plots, and maybe we'll go over that somewhat briefly. Okay? Alright, we're going to skip that discussion point. So, measures of central tendency, they indicate the middle of a data set. The mean, median, and mode are the most common measures of central tendency, and those are the ones we're going to use today. Now, you've seen these before, and you might be able to give your own definitions, but we'll just go over these briefly. Well, the mean is the average value of a data set. Okay? Well, if you remember, you're just going to add all the values up and then divide by how many there are. That's how you find the average of something. The median is the middle value of a data set. The middle value and moreover, if it's a data set that has an even number of values, it's the mean. It's the middle value of a data set if it's odd, or it's the mean of the two middle values in a data set. And that would be if there's an even amount of things in that data set. Then you would just find the two middle values and then find the average of those two middle values, and that would be the median. Okay, the mode is just the most often or the most frequently occurring value. The most frequently occurring I don't know how to spell occurring. I think it has one R. Occurring number or value. And in parentheses, values, you could have more than one mode in a data set. Okay. So, to find the average, well, if this is our data set up here, 1, 2, 3, 3, 4, 5, 5, 9, well, to find the average, you just sum those together. So 1 plus 2 plus 3 plus 3 plus 4 plus 5 plus 5 plus 9. And then you divide by how many there are. There are 8 elements in this list. Divide by 8, and we find that the average, or the mean, is 4. So the mean of this data set is 4. And the median is what we get if we find in the middle. Well, again, there's 8 things in this list. It's going to be the two middle things. Well, I go 1, 2, 3, 4. Okay, well, let's go there. And then we go, well, I guess you can do the median in a couple different ways. You can do this, which is probably what we were taught in elementary. You can go, well, we go 1, cross off each side, work our way to the middle, and we find these two values. Or, since, I guess when this is an even set, you know that there's 8 items, and you know that 4 is going to be the halfway point for each side. So 1, 2, 3, 4, here's your value, and then the other one right next to it, 1. Or you can go backwards, 1, 2, 3, 4. So it's going to be the average of these two values. Well, 3 plus 4 divided by 2, you're going to get 3.5. So the mean is the median. The median is 3.5. Okay, the mode is the most frequently occurring. Well, we have a 3 occurring twice, and we have a 5 occurring twice. Those are our modes, 3 and 5. So a quick review there. That's something that you guys have worked through with a lot. A data set is said to be bimodal if it has 2 modes. Bi means 2, modal, that kind of makes sense. So typically if a data set has 2 or more modes, it's not particularly useful to use that measure of central tendency. The most frequently used measure of central tendency is going to be the mean and the median. And you're probably thinking, well, when the heck would we ever use the median? It seems like the mean is usually the best example. Okay, now, a case where the median is probably going to be more useful is when you have a data set and you have outliers. So, if you remember what an outlier is, it's just something that doesn't really seem to fit in that data set. And we'll talk more specifically about what an outlier is in a little bit. But medians are going to be more useful when you have like a data set and you have outliers. And the reason that is going to be more useful is because a mean would still take into account those outliers, and that would be finding the average value with either a really small number that shouldn't fit in the data set or a really large number that might not fit within other numbers in the data set. So that's where median is more useful. So for a real life example, a lot of times you'll see median used when you're talking about household or house prices and like the housing market, or a lot of times you'll see median used is in like household incomes in certain areas. Usually the median is more useful because it'll get rid of the outliers of someone that makes maybe like $1 million relative to everyone else in the area that might make like upwards of $100,000 or somewhere around there. So kind of median's more useful in those types of instances when there are outliers. Okay, so let's move on to an example of finding measures of central tendency. We have a frequency table shown below, not the graph, but kind of the chart, or a table, I should say, not the graph, that's the table. Shows the number of job offers received by each student within 2 months of graduating with a mathematics degree from a small college. What are the mean, median, and mode for the job offers per student? So when you're reading this table, you want to be careful. The students here, this is a frequency chart, so it means this is how many times these occur. So the number of job offers received happened twice. So there's 2 times where a job offer was 0. So we want to know the mean, median, mode of job offers. Well, there's going to be 0, 0. There's going to be 1 twice. There's going to be 2. 4 students had 2 job offers. So we have 2, 2, 2, 2, 4 times. We have, well, 5 students received 3 job offers. My 3 there. And we had 2 students receive 4 job offers. Okay, so we want to find the mean, median, mode for the job offers. Now another way to express the mean, and we're going to see this a lot in the statistics unit, is x bar. That's just another way to write the mean. Okay, so x bar, the mean, is given by, well, we're going to average, we're going to add all those values together and then divide by how many there are. Okay, well, there's 2 zeros, so 2 times 0. There's 2 1s, 2 times 1. There's 4 2s, 4 times 2. Plus, there's 5 3s, so 5 times 3. Plus, there's 2 4s, so 2 times 4. That's the same thing as just adding all those things. It's just shorter. And then we divide by how many there are. There are 15 things. We're going to get 33 over 15, which is about... Not about, it's exactly 2 2/10. So that would be the mean. The median of this data set is just that middle value. Well, if we know there's 15 values, we've ordered them from least to greatest. Instead of crossing off and working our way to the middle, what we can do is, well, if there's 15, we know that the halfway point is going to be just above 7, right? Because, well, if it was 7, technically 7.5, right? But it's going to be in the middle. So we're going to go 1, 2, 3, 4, 5, 6, 7, and then 1 more would be exactly in the middle. And we can verify that this should be our median because, well, since there's 15 things, there should be 7 this way and 7 this way. So basically you count the one less than the middle value if it's odd, and then move to the right one. So 1, 2, 3, 4, 5, 6, 7. Or you could count backwards too. 1, 2, 3, 4, 5, 6, 7. And then 1 more in the middle would be our value there. If it's an even number, you kind of have to do what we did that first time. Is, like, for example, if this was 14, then you would do 7 again. But just keep in mind that you're going to have 2 values, and they're going to exist at that 7th spot on each side. All right, now... our median is then, we just found it, it's 2. And our mode is the most frequently occurring number, and that's what's nice about this frequency table. It tells us that the most frequently occurring number is 3. It happens to 5 students. So our mode is 3. Okay? That, just a quick recap on how you do those. The frequency table might be somewhat a new application, but that should be mostly review, I'm assuming. Okay, so we're going to talk more specifically about what an outlier is. It's a value that is substantially different from the rest of the data in a set. So, well, it's easy enough to kind of visualize what an outlier is. We have this data set. We have, well, if you want to, you can arrange it in numerical order, and let's go ahead and do that. We have 56. The next highest number is a 59, then another 59. It's a small data set, so this isn't too much of a pain in the butt. And then we have 65 and 65 again. followed by 73 and 98. And right away, you might think, and you could probably identify that maybe 98 is an outlier. And based on what we've done so far in your mathematical experience, you might just say, well, that's an outlier. It seems to be different. But we're going to talk about how can you verify that that's different? Okay? And formally, something is considered an outlier if something is an outlier. I say formally and then I say something is an outlier. Something is an outlier if it is greater than quartile 3 plus 1.5 times the interquartile range. And these might be some new words to you, and you're probably thinking, what the heck does that mean? We'll talk about that in a little bit. So it's an outlier if it is greater than quartile 3 plus 1.5 times the interquartile range, or is less than quartile 1 plus 1 point, or minus 1.5. Minus 1.5 times the interquartile range. Okay, so these are how you can formally show that something is an outlier. But to do that, we need to talk about what quartiles are and review what a range is. Okay, well, you might recall range is just the difference between the highest and lowest values in a set. Okay. It's the difference between the highest and lowest values in a set. Quartiles, it's just something that divides data sets into 4 somewhat equal parts by applying medians. So a quartile divides a data set into somewhat more or less 4 equal parts. Sometimes you're not going to have exactly the same amount of values in each quartile, but there's roughly 4 equal parts using median. So let's talk about that. Well, let's divide this data set up here, that we did in the orange. Let's divide that into quartiles. So you're going to have a quartile 1, a quartile 2, and a quartile 3. And you're probably thinking, well, it's quartiles. Shouldn't there be 4 of them? And we'll discuss in a little bit why there's not. So it's going to exist chronologically. It's going to go quartile 1, quartile 2, then quartile 3. So really, you want to start by finding quartile 2. That's your middle value. That's just the median. So whatever the median is your quartile 2. If you're working with an even data set, you have to make a new kind of quartile 2. Okay, well, our data set has 1, 2, 3, 4, 5, 6, 7 numbers, so it's odd, so we're not going to do that. But I'll talk about that. Anyways, since it has 7, we know that it's going to exist, well, halfway between 7 would be 3.5, so it's going to be right between the 3 spots. So 1, 2, 3, here's our quartile 2. It's exactly 65. Okay, that's right in the middle. That's where quartile 2 would be. Then quartile 1 is just these values, all the ones to the left of quartile 2. Quartile 3 is all the values to the right of quartile 2. Okay, so we find quartile 1. It's the median of these 3 numbers, which is going to be 59. So this is quartile 1, then 1, 2, 3. This is quartile 3. Okay, now if I had an even set, like let's say I had 56, 59, 59, and I don't know, maybe a 60 in there. Okay, then my quartile 1 would be, well, it'd still be 59. That wasn't a great example. Let's go over to this side. 65, 73, 98. Let's say this was 100. Then my quartile 3 would be the average of 73 and 98, which is, let me get my calculator out, which is 85.5. So if that was the case, our quartile 3 would be 85.5. All right, now, the reason we just found these, and I guess I need to rewrite what we have, quartile 1, quartile 3, is because our interquartile range is just what you get when you take, it's the range of Q3 and quartile 1. So to find the interquartile range, it's just the range of Q3 and Q1. It's just the difference in those values. So, knowing all of this, we can then verify, well, we thought that 98 was an outlier, but is 98 truly an outlier? Well, it has to follow one of the following conditions. It has to be greater than quartile 3 plus 1.5 times the interquartile range, or less than quartile 1 minus 1.5 times the interquartile range. And, well, you clearly know, since it's a larger number, it shouldn't be quartile 1 minus a value. We should test it using quartile 3 plus 1.5 times the interquartile range. Well, quartile 3 is 73. So, well, we take 73 plus 1.5 times the interquartile range, which is, well, that's just quartile 3 minus quartile 1, which is going to be 73 minus 59. You plug that in, and you should find that you get, what do we get? You get, oh, I thought I worked this out on my notes. All right, I guess I'll just do this on my calculator now. So, 73 plus 1.5 times, well, 73 minus 59, and you get, whoops, not 590. And you get 94. Okay, well, is 98 greater than that? And the answer is yes. So it is. We can verify. So we know 98, or we could also say anything above 94 would be an outlier. Okay, that's how you formally find if something's an outlier. We're no longer just going to kind of eyeball it. You can verify that. You can verify that. And it might not be as much of an outlier as you originally thought. It's only a 4 above that outlier. Okay. We're going to move on. That's just another example of finding mean, median, and mode. Box and whisker plot is just a way to display data that uses quartiles about the center box, the minimum and maximum values form the whiskers. You've worked on that in the past, maybe in middle school you've worked with box and whisker plots. Basically, you have your minimum and your maximum value, so I guess we can make one very quickly. We can make one. You have to visualize a data set. If we're going to work with this data set again, since we already have it organized, what you need to do is, again, just find that quartile 1, quartile 2, and quartile 3. And those quartiles are going to kind of be the, they're going to be the box, if you will. So if I have my number line, I'm not actually going to draw my number line initially, we'll draw it at the end a little bit, but our quartile 1 is going to be the first part, then our median, that quartile 2, is going to be the second part, and actually maybe, you know what, I should draw a number line. So we go from 56 to around 73, so let's just go by, start at 50, go by maybe 5s. 75, 80, 85, 90, so on and so forth. 95, and then 100. And we go all the way down to, well, 56. We're good there. All right, so we're going to draw our box and whisker plot. We'll do it in orange since that's what our data set is. 50, quartile 1 just becomes the first part of that box. So this box is really defined by these quartiles, these median values. Okay, so 59 is our first box. And then our median is the middle value of that box. So we go to 65 right here. And then our upper quartile, quartile 3 is 73. Right here. So this is our box that we make, where this is quartile 1, quartile 2, and quartile 3, and they have these values. Okay, and then the whiskers are just basically the extremes of the data set. They're the lowest and the highest point. It kind of shows you where the data ranges from. So we start at 56, that's going to be right here, and we go all the way up to 73. Now if you're including an outlier, or excuse me, we go all the way up to 98. Okay, but this is an outlier, and since this is an outlier, if you say, well, that's an outlier, this is really what our data should look like. If we omit that outlier, then you would really only go to 73, right about here. Okay, so that's kind of the difference with that outlier. Notice how drastically different that looks when you don't have that outlier included. If we were to include it, it would extend way out here. So, if you want to kind of do that, you can, another way that you express that there's an outlier is you kind of draw it, but then outlier. All right, so that's kind of a crash course in drawing a box and whisker plot / review. We're not going to worry too much about that, but it does involve those quartiles and the min and maximum range values, or excuse me, the minimum and maximum values of the data set. All right, the last thing we're going to talk about is percentiles. Percentiles. So, a percentile is a number from 0 to 100 that you can associate with a value x from a data set. It shows the percent of the data that are less than or equal to x. If x is at the 63rd percentile, then 63% of the data are less than or equal to x. So, really, the definition of what I want you to take away here is that a percentile, it shows the percent of data that are less than or equal to a certain value. Okay? It shows the percent of data that is at or below an amount in question. Now this next example, it can be a somewhat confusing example, so I'll make sure to talk about it carefully. A lot of times you'll see percentiles when talking about like test scores for ACTs and stuff like that. So for example, we have scores for an SAT in a given year. So a score percentile, it represents the percentage of scores that are equal or below a certain score with a given sample. We know that percentiles are just the percent of data at or below an amount in question. So the 75th percentile for incoming freshmen is 1400. That's the score. So if you get a score of 1400, you're in the 75th percentile. Okay, now you want to be careful here. This is where students get confused. They go, oh, 75% of the students scored 1400 or below. That means they're in the 75th percentile. Okay, these students that scored 1400 or below, okay, that is okay. So right here, this is where this diagram is somewhat confusing. Right here is the 75th percentile. Okay, these students to the right, these students are in the 75th percentile. They scored in the 75th percentile. Okay, so it seems like the students below it should be in the 75th percentile, but 75% of them are below that score, so they are not in it. It's the students that are at that value or above it. So the 75th percentile is, well, the higher scorers. The higher scorers. They scored above 1,400 points on that SAT. So, finding percentiles, I guess actually a little bit before we move on. So that kind of makes sense because we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're going to assume, for the sake of this graphic, that these students are ordered in chronological order based on their scores. Well, these two students got at least a 1400. So 2 out of the 8 students, well, that is exactly 25%. They're in the upper 25%, or they're in the 75th percentile. Because because 75% of students scored 1400 or below. So really, I would say that diagram is almost more confusing, but to clarify, these kids are in the 75th percentile because 75% of the students scored below the 1400. So we can assume these kids got at least 1400 or above, these two students here. Okay, so let's move on to an example. Here's an ordered list. Thank goodness it's long. That is ordered for us. Here's an ordered list of midterm test scores for a Spanish class. What value is at the 65th percentile? What value is at the 65th percentile? Well, how many values are there? And we could count them, and it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, there's 20 values. There's 20 values. Well, we're saying what value is at the 65th percentile? There's a lot of different ways this question can be asked, but essentially the way that you can find it is the same process. What value is at the 65th percentile? Well, if we have 20 items and we want to know, well, what's at the 65th percentile, we can take that times 65%. So, well, 20 times 65% or 0.65 gives me, well, what does that give? It gives me 13. So we get 13 here, which means since this is, you want to be careful, it's not the value 13, that's not the number, it's the 13th item. Since we have 20 items, well, at the 60, and they're ordered in ascending order, you have to have them ordered for this. Well, the 13th item should be the 65th percentile. So we go up to the 13th item, which is right here, 82, and sticking to our color scheme. Well, that means that the 65% of this data, and remember that it's at or below that value, 65% of the data here is going to be at or below that. Well, we can stop with this question technically, but I want to keep talking about it. We know that, well, what value is at the 65th percentile? It's the 13th item in the list. 82 is at the 65th percentile. Okay? Which means, if we wanted to, is there a red highlighter? That'd be neat. Bum, 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 bum. There sure is. All right. Which means these values in the red they're the 65th percentile. Okay? They are in the 65th percentile. Okay, 82 is at a 65th percentile. The things in red are the 65th percentile. And you can always double check, well, do I need to include the 82 down here? Well, if you do this 13th item, well, there's 13 out of 20, that makes 65%. Then we have these, well, 14 through 20, that gives us 7 items. Those 7 items out of 20 are going to be 35%. Okay, so really if you're in the 65th percentile, you're in the upper 35%. A lot of times you'll see percentile used with like baby statistics. It's kind of a funny way to say that. But really they'll talk about baby weight. They'll be like, your child is in the upper 75th percentile for weight and the lower 25th percentile for height, which basically just means their child is short and wide. So percentiles are used a lot when talking about babies, or in a lot of times when talking about score percentages, and I guess I should say baby weights and heights and things like that. So they are used quite frequently. They're somewhat confusing, but they're not a super difficult concept to grasp. Okay, that's all we're going to cover today. Make sure you're working on your progress packets, and as always, stay safe out there.